Good morning, everyone. We'll get started and keep on time. Our first speaker is Matthew Polinsky, and he will present an overview of the activities of KRTP for 2024 and plans for 2025.
All right, thanks. Good morning. I'll just tell you a little bit of what I'm going to cover today, talk about the program, kind of staff and funding status. We'll go over a couple of research projects, and then talk about general activities and services and our planning for this upcoming season. I guess I just want to mention again that the KRTP was established with 4 pillars in mind: applied research, services to beekeepers, communication, and education. And since I have many people in the room, I'm just going to clarify one other thing. I think there's sometimes some misconceptions that the tech team does inspections or anything regulatory, and we do none of that. So just with that, I'm going to continue. So I've been here since April 2023, and this 2024 season, we were able to hire a second full-time staff member, Amanda Turf. Amanda, if you want to just wave to everybody so they know who you are. So that was major progress. You've probably heard me talking about it in the newsletter and stuff. We do have casual staff throughout the season. Laura Weens is here as well. You're probably familiar with her. And Chiru Sharma, who's a grad student of Dr. Curry, who's just finishing up now. So they help us both in the field and lab work and any other type of work, administration stuff from time to time. So in terms of funding, we're mainly funded by the Sustainable Canadian Agricultural Partnership. This is a 5-year agreement. So we'll be entering our 3rd year of that funding cycle. We also have continued to receive generous support from the Manitoba canola growers. Support from Beekeepers has been really helpful in getting things done in terms of just making those connections, talking, understanding issues, but also there's a few beekeepers that have been very helpful with providing hives and things like that. So I'm going to talk about the GreenLight Biosciences Norroa control field trial first off, and this is going to probably be the largest part of my presentation. So this will go for a little bit. So just before we get started, I wanted to make a note that this product has not been assessed for registration under the Pest Control Products Act. It cannot be manufactured, imported, distributed, or used in Canada at this time unless explicit authorization has been obtained from Health Canada to use this product for the purpose of conducting research under the Pest Control Products Regulations. So GreenLight acquired the research authorization for us to test this product in Manitoba, and they had a couple of trials in other parts of Canada. So just GreenLight, they've been here the past couple of years and they've made that abundantly clear, but I want to note that before moving forward. I'm going to give you just a 30-second refresher on how this miticide works. I know they've talked to us a number of times. They've been to our field day this past year. But what it does is, this is their new name, by the way, it's Norroa. So as they get closer to hopefully getting to the market, they've given it the name Norroa. It targets reproducing mites in the brood cells. So this doesn't kill phoretic mites, it prevents mites from reproducing. So the idea is to stop them from existing in the first place. So it's double-stranded RNA, and it's formulated into a sucrose solution, a syrup, and packaged into a pouch with the perforated holes on top. So you can see right here what that pouch looks like. The bees just go on top and suck it down. The pouch is placed on top of the frames. The bees take the solution and distribute it through the brood nest. So the mode of action is that the nurse bees deliver brood food containing Norroa to the brood cells. The varroa mites hiding in the brood cells come in contact with brood food containing Norroa, absorbing the dsRNA, which targets the production of a protein in the mite. This inhibits the mite's ability to reproduce, resulting in control of the mite populations. So just a quick refresher, and we can talk about the trial here. So what we did this year in 2024, in 2023 we had a kind of a slightly different setup. We had more hives, but this year we had a smaller trial with 64 colonies, and this allowed us to have a lot more control over the status of those colonies going in, which I'm going to explain here in a little bit. We set up the colonies on May 17th, and the trial start date when they received treatment was June 25th. The end of the trial was October 11th. We could have actually gone a couple of weeks further as per the protocols, but given that it was the end of the season and given that we had already seen kind of the differences between the treatment groups, it was time to wrap it up, so it worked out well. And the initial mite pressure across all the colonies was 0.6%. So before we get into numbers and graphs and charts and stuff this morning, I'm just going to tell you a little bit about the colony setup, because that's a really important part of what we were doing and how we could test the product. So I had in the, how did we get to this across all the groups, I guess, this 0.6%. Coming out of the winter, I had about 80 colonies, and they were all uneven population sizes, uneven mite loads in those colonies. And then when I have I had this plan to run 64 colonies, and what I wanted to do was standardize the mite populations, because if you're testing the product, you could see, well, maybe it worked better in this hive or not as well in this hive, but if it's different mite populations in different hives, it's not exactly clear. So when I have a question like this, research related, this is what I want to do, how do I do it? I think I typically go to Derek, Daryl, and Rob and give them my first, okay, this is what I'm doing, what do you think about this? So in the end, Dr. Rob Curry was very helpful in helping me kind of set this up and understand how I need to set up the colonies for this to go well. So again, I had colonies that were all over the map. So what I did was I had checked the mite levels in all those 80 colonies, assessed how many frames of bees and how many frames of brood. We did calculations guessing how many mites we had in total, and then we figured, okay, now we need to redistribute all these. In the past, we had kind of just equalized colonies and hoped that the mite populations were equally distributed, but what we did in this case was I had my 80 colonies, some with high varroa and some with low varroa. The U of M was very generous in throwing in 25 colonies that they had identified with detectable mite levels. So I said, oh, you have mites? I want all of your colonies with mites, please. And so we had about 100 something, I can't remember exactly right now, but just over 100 colonies. And what we did was we separated the low varroa groups, high varroa groups, and we went through them and we made packages from them. So I'm going to show you a little bit about the setup. So I brought my colonies back to campus, flagged the different mite level groups, eventually removed all the queens. Then we had this equipment, well, I don't have the equipment, but that's why this is something that's done in bee research sometimes. So the University of Manitoba has the equipment to be able to make those packages up and standardize the populations. So we shook the 100 hives into 2 boxes like this. There's just 1 box showing there, but we had 2. One with high varroa mites and one with low varroa mite loads. All of the brood from those hives went into incubating rooms in the building, so it was saved. But that's what we needed to do to get to the point of standardizing the levels. These went into the overwintering building at a cool temperature overnight, give them about 5-6 frames of honey, and they basically consume that overnight because there's 30 kilos, well, a bit more than 30 kilos of bees per box there. So after that, we got in here the next day, towards the end of the day, because we wanted to install the packages at the end of the day, and we needed to set up all that equipment we just, emptied in the field. So there's myself and Amanda in here, and we need to scoop out the bees from and weigh them per each different box, weigh them, and then make up a package in equal parts to standardize the mite populations. So yeah, we went through all of this and we got the truck loaded up, and it was a pretty wet week. We had some other truck issues, so we had a borrowed truck, we had our KRTP little truck on there, and I was planning to take these out to a site Ian had prepared for us. It was quite large, and I needed a large site. And once I got them loaded up, I think I got into the truck. It's 7 p.m. on a Friday night, and Ian texted me and said, "Don't come here. It's raining. You're never going to get in that site." So this picture Amanda took of me is me calling every beekeeper in the Winnipeg region, trying to figure out where I can install these packages. I think it was a long weekend too, so a lot of people were taken off. Ended up texting Zoe, who's here, and she said, "Yeah, you can put those at the university site." So that's what we ended up doing. All this to say is also Amanda's second week on the job, and she's probably wondering what the heck we're doing in Manitoba, scooping bees in an indoor wintering shed and trying to load them up with mites and all this stuff. So we did get out there, and it started to rain. So luckily we had a tent, and we ended up kind of installing the packages in the dark. And this picture shows nicely installing in packages in the dark, but of course the reality is actually working like this. So I had never installed packages or queens at midnight, but I guess there's a first for everything. Anyways, we got that set up kind of in that first yard, and later we moved them to a site I had found not too far from the city, and they went into the different spots for the protocol. So we had 4 hives per mini site, and all of these different colors you see here are the different treatment groups. So for example, the yellow here, that's the untreated control. So there'd be an untreated site here, then there'd be one over here, one here, one here. So we could minimize drift. The other thing about that is, just that there was significant land markers, tree lines, ponds, some other stuff out here to help minimize drift. So as you can see, these colonies started off pretty small. They took us some time to get them sorted properly, but they grew really well. The site had really good forage, and they picked it up. And this is a picture of midsummer. They were producing honey. So let's get to the trial and the results a little bit here. We had 4 different treatment groups. So one was the Norroa. One was Norroa plus oxalic acid dribble. The third was an chemical industry standard, which we used Apivar. And the fourth was untreated control. So this group did not receive any treatment. So, what we want to do is have those mite populations standardized and then see how well these treatments can suppress the mites compared to this control, which we can let those mites grow unfettered. Statistically, there is a difference here between both Norroa groups and the control. So if we're just thinking about the control up at 30% and the Norroa groups at 10%, I mean, there's a pretty obvious difference. As beekeepers, we can see that, and statistically, it's there as well. So I think that's it about that, but I guess I can say a couple of notes about, I think I have a slide on this, actually. Well, first we'll talk about post-trial. So as soon as that trial ended, October 11th, at the end of the day, I didn't waste any time, and I stayed, and I went with a round of oxalic vapor. So I did end up doing 4 rounds of oxalic vaporization at 3.5 to 4 grams per dose. When I came back to these colonies on October 30th, I wanted to see what they were heading into winter like. The trial had finished at this point, right? So I'm just trying to take care of these colonies before salvage what we can. I should note, there's variation in those groups, right? And that's taken into account in the statistical analysis, but there are some colonies that, for whatever reason, swarmed, superseded, had low mites, and then in some others there was maybe more drift and had more mites. So there were some colonies in there in good shape, but in general, there were high mite levels, treated them 4 times, went back October 30th, checked the cluster sizes, and also took a scoop of bees to check for varroa. Most of those samples came up clean, but we had 4 colonies with below 1% levels, 3 colonies with 1 to 4, 3 colonies with 6 to 10% levels, and 2 colonies that were at exactly 16%. So when I packed up all of these colonies from the trial and took them to their indoor wintering facility, I had 52 colonies out of 64 alive, which is still kind of surprising. And apparently, some of them are still alive in Ian's shed today. So I'm hoping we have some of those come out. And it'll be really interesting to reevaluate those. And just, again, aside from the trial, but look at what were the mite levels through the season, what were they at the end, and which ones made it. So just a couple other notes from the trial. We did notice in the field that we did have the untreated controls and the chemical standard groups declining at the end. We noticed that they were consuming a lot more food. They were trying to brood up very late, and there was a lot of that bald brood there. So nothing too surprising there. And we expected we do have some amitraz resistance in that mite population, and that's why we saw that chemical standard apivar underperforming a bit. And I mean, that's not just suspicion. What I did was a little bit of testing to be able to follow that up. So in September, I did a quick field assay that's using this kind of cage bee, kind of like a Pettis test. This is called the apiarium, or in the States, they call it a Rinkovich. So I used that. I took a quick look, and then when I had time later in the season, we went back in October and did another set of tests. And from those tests, I could see that the amitraz resistance, apparent amitraz resistance in that mite population, was at about anywhere from between 40 to 60%. So, let's say 50% resistant. I had sent mites off from earlier in the trial, kind of a pooled sample of mites from the entire trial to the NBDC, and usually it takes a long time to get those results, but we were lucky to get those back. So the genotyping results on some of those mites, so the pooled sample I sent, those look for a mutation in the mite that's associated with amitraz resistance. So it's one of those signals that you could have resistance in your population. And they found that in up to 50 to 67% of those mites. So the other thing is that we kind of have 3 layers here. And this is, again, aside from the trial, but just interesting to know that we also have the field data, right? How well did the apivar work in comparison to the control? And we can see that, and in comparison to another treatment that we put on. And we can see that the apivar didn't perform excellent, I would say, in this case with this specific mite population. And that's going to be different depending on your operation and your mites everywhere, right? So this is just one example. Moving forward to a little bit about just the health statuses of the colonies throughout the trial. We didn't see any difference in colony growth. So despite any of the different treatments, and despite the control group either, they all had similar colony growth population size throughout the trial. So this was the untreated control. This one would be the chemical standard Norroa, and all the blues are pretty much equal, all the grays, all the reds. So there was no major differences in that. A quick note on the regulatory status. Is not entirely my place to talk about this, but I asked GreenLight what I could say because I know beekeepers are curious and I know the industry is curious and you want to have some answers. So they told me a couple of things I could share with you all today. First off, in the US, the federal registration submission was made in February 2023 to the EPA. It's currently under review. They say approval is expected soon. In Canada, research authorizations for testing the product have been received for this past year and this coming year, and submission to the PMRA is pending. So I think that they have some expectations to submit it relatively soon. In Europe, small animal use approved and tolerance exemption of honey granted, in honey. The tolerance exemption for this in honey has been granted. And again, submission pending, New Zealand submission pending. So Canada is not far behind. I mean, US is the only place it's been submitted and it's in the process, and now they're preparing these submissions, so that's good news. purpose and reason maybe for another trial. Just had a quick chat with them this past week, and essentially what you saw me presenting now is really important data for them and important data for us to see, number one, that the product works, and for them to show that it works when they want to, try to register it. But going forward, they're now kind of more open to this idea of let's test it under more regular producer conditions and see what we can see not only this, let's say, during the season, but for winter survivability and such. So we talked about the Manitoba timeline under regular producer conditions, typical fall interventions would be in place, and looking at winter survivability. And just to better understand the efficacy, usage, and integration of this into our current practices. So this is a work in progress, but I think it appears to me a good idea to potentially try one more year with this here. Just gonna actually move forward. So I'm checking my time. What time is it actually in the? You have 15 minutes. Okay. I'm gonna try to stand up. If you can't hear me, tell me, because I'm crouching down and hurting my shoulders. So that wasn't enough work for me and Amanda. We wanted to do more things last year. So we talked to Dr. Sarah Wood. We were in contact with her at the University of Saskatchewan, and I said, I don't have any colonies to run any trials. All of mine are tied up, but if I can use producer colonies, sure, let's do something. We ended up collaborating with Phil Valdez and started preparing colonies in August. So we were going through them and checking mite levels, surveying them. What we wanted was to test oxalic acid strips, the glycerol strips, in an indoor wintering setting. So we don't want too many mites in those hives that they're going to die over winter, but we want enough mites in those hives that we could actually test efficacy, because if you can't drop mites, then you can't really check if it's efficacious. So we started in August going through hives and taking a look and trying to prepare them right. This is probably going to be a talk for next year, but I just wanted to tell you about what was going on since the fall and what's happening right now in Phil's shed. We have three different treatment groups, I guess, but different doses. So we have we use the Viroxan strips. The choice to use that was, we had a couple of different options, but one of the other strips we could have used would have needed 2 applications, and this just needed 1. So there was a few reasons why we chose this. We don't need to disturb the colonies as much. So we do a high dose, medium dose, low dose, Apivar group, and a sham treatment group. So just a strip, a Viroxan strip with no oxalic in it. So just a quick picture of Sarah and Alvaro. They came out from Saskatchewan and they helped us with the initial trial evaluations. We looked at cluster sizes, took samples for Varroa, Nosema, and we separated the groups accordingly. So yeah, more on that to come. Sarah has a multi-year project looking at optimizing the use of oxalic acid. So she's specifically going to look at different ways we can use it over winter. And this is kind of before that formal project starts, and work out some of the kinks and try something different with the strips. So 2025 plans. I think I'm going to come back to this more at the end of the day. At the end of the day, we have a panel with me moderating, with Danny Glennie, Bob Binney, Derek and Nuria. So we'll talk a little bit about this a bit later on, some of my observations with the KRTP, but I would like to look a little bit more about understanding the variability in the colonies, and this may be a research project, but this just may be an extension project. I know that when we were going through the colonies with Phil, for example, this fall, and we went through, I guess, 80 colonies to get an idea of what was happening. And he looked at the results and he's like, oh, I had no idea that I had so much variability in those mite populations and what I was actually controlling. So that was kind of one of the impetuses, but we'll come back to that later. We talked about syrup a lot last year. Dr. Curry gave a talk and he's been working on that for a long time. KRTP, myself, I was involved with him last year. And out of that, one of the things we wanted to know was, we wanted to know, and I think it's one of the most common questions I get from beekeepers, is if I put this in my syrup, is it going to help either my bees, or is it going to help preserve my syrup or make my syrup last longer, or what's it doing? I guess our first question is evaluating the impacts of additives in the syrup. So not especially on the bees, but first, the things that we're putting in our syrups, does it change the syrup? And does it change its longevity? So that's something we want to look at, that we could do a little bit of lab work, and we can do some kind of real world conditions as well. And Dr. Curry is quite busy last year, but we're going to get Dr. Morfin on board, Dr. Curry and myself this year, it looks like, so we'll be able to put something together. So Dr. Morfin mentioned this yesterday, the screening of colonies, and collaborating with the KRTP on this. It's something that they're doing in BC, and that since the KRTP is already doing freeze kill, we're already doing the UBO, which we've started this year for producers who want it. Basically, all we need to do is add in the low varroa growth part, and the U of M is going to be taking care of all of the marker-assisted selection type of work. We'll be collaborating on the entire project, of course, and sharing some of those responsibilities, but I won't talk about too much about this just because my time is running short, and I want to leave a couple minutes for questions. But if you're interested in this, come talk to me, send us an email. 2025 plans. Just in terms of some of the minor activities that are ongoing, as an example, like with the Canadian Bee Gut Project, you can look that up. It's very well documented on their website. I sent out some information on it and posted it on social media this past year. But there's some research being done on gut health out of Ontario, and they're asking from samples from across Canada. So one of the things that KRTP can do and continue to do is, while we're doing these larger projects, we can also kind of tie into these and say, okay, you're collecting samples, we know beekeepers, we'll see who wants to participate, and send that type of stuff off. With pesticide monitoring, it's been a hot topic yesterday, it's been a hot topic all year, for many years. There are a couple of ways to test for pesticides in the colonies. There's something out of Europe called an AP strip. This particular one I have shown here is a researcher at the University of Regina who has been working on this and developing methods for in-hive detection. She also uses an air sampler in the bee yard, and then they look at this. So can talk more about this in the future. It's still kind of fully in development. Again, we're not gonna run this in your yard and then you're gonna get results tomorrow. This is something that's more long-term, and we're just kind of connecting with beekeepers, getting that going, and working with other people in the country. Again, we continue working very collaboratively with the University of Manitoba and with Manitoba Agriculture, and relationship building with industry. Again, I noted in the intro here, one of the things I don't do is inspections. One of the things I don't do is anything regulatory. However, you'll hear my name mentioned, and I mention the U of M, I mention Derek, and vice versa. And there are a lot of things we overlap on and talk about and work on together. And visiting beekeepers, attending meetings, planning events, as I've been integrating myself here into the province and getting the program going. We're planning events is always a big one, and help from the MBA is helpful, but we're going to try to do more of that. And yeah, visiting beekeepers, one of my favorite things to do, but it's a lot of time we're already spent on the road, so I'll try to get around more and more. Since I arrived in the province, what am I at for time? 8 minutes. Oh, good. Okay, so since I arrived in the province, there's been a lot of talk about reestablishing a queen breeders group. I think we all know that self-sufficiency in Canada is important, domestic self-sufficiency. We also know that self-sufficiency within your own operation is important. And this type of group could be about breeding the best bees. It could be about sharing genetics. It could be about developing or sharing your best practices on overwintering nukes and stuff with your neighbors. It could be about anything you want, but the group was first established in 2002, and it ran for quite a while and did a lot of really good work with beekeepers around the province and with the U of M. And I wrote a brief history of that based on some meetings and posted it on the MBA website, so please check it out. But there's been a lot of talk about reestablishing the group. We've taken a number of steps to do that, and we had our first meeting this month We had a Zoom meeting, 25 or over 25 people attended, and we're going to be having a second meeting in March. What we really need to figure out now is who wants to be involved, how involved do you want to be, and what are the goals that the group can set together. And the KRTP is not there to define what you want to do or guide it. The KRTP at this point is only there to support and help in organizing, so we're going to continue to do that. A couple other announcements before I go. Since we now have Dr. Morfin in the province whose first language is Spanish, I thought this would be a good opportunity to offer to the industry any type of support that you might need with skilled Spanish-speaking workers that you have. So we are offering an online workshop for skilled Spanish-speaking beekeepers. And to put this on, we need to hear back from you what you need. Some of your beekeepers have 20 years of experience and 20 years of experience in Canada. They might not need certain things. Some of them might be new. Some of you have very good in-house training programs and mentoring beekeepers within your operations. So we just want to know, what are the needs? Is it about Varroa monitoring? Is it about general pest and disease? Is it about communication issues, or just general seasonality of Canada versus subtropics and stuff? So we want to do that, but we just need to hear from people. Intro to Queen Rearing Workshop happens every year. The KRTP collaborates with Mr. Jonathan Hofer at Scott Creek Honey Farms, and we fill up every year. We didn't have enough participants to run 2 workshops this past year, but every year we sell out, so we continue doing that. It's a really fun day. And the Canadian Honey Council and the Canadian Bee Tech Transfer programs have been organizing a series sponsored by Vito Pharma. It's going to be a webinar series. We really wanted to put something on now rather than wait until the fall. So we're putting on a first webinar entitled Staying Ahead of Varroa, Challenges and Strategies. So our 2 main speakers here are going to be, most likely we have lined up Jeff Wilson from Saskatchewan and Julie Furlan from Quebec, and they're just going to talk about the different approaches to Varroa in their provinces. And then we'll have a guest speaker out in New Zealand who has done a lot of work on integrated resistance management for the acaricide use on Varroa. So he'll be pre-recording and hopefully be able to show up for questions from everybody. Tentatively scheduled for March 15th, a Saturday at 11 a.m., but the promo information will be coming out soon, and we'll make sure we get it out to all beekeepers' emails. So thank you to our sponsors and collaborators, especially the SCAP. And our local bee suppliers are always very helpful, working with us to supply us with suits, smokers, anything we might need, supporting field days. And the Red River APRS Association as well does support the KRTP. So thank you for that. I'll take a couple questions until the moderator kicks me off. I will be available all day to talk, and I'll be back here kind of at the end of the day with some of the other guests to talk about Varroa.